I have an equation with an x on both sides and they're both in the exponent. It'd be great if the bases were the same. If the bases on both sides were the same, I could just set those exponents equal to each other. But this base is 4 and this base is 16, and I don't know how to break this to you, but 4 is not the exact same thing as 16. I can't multiply or divide or anything like that. What I'm going to have to do is try to find a way to write them with a common base. And as I look at this, I think about 16. I'm wondering, is there a way to write 16, something that's equivalent to 16, but instead of using a 16, I can use like 4 to some power. 4 to some power. You know, and as you think about it a little more, you might realize, yeah, 16 is the same thing as 4 squared. And so instead of saying 16 to the x minus 1, I'm going to take that 16 and write it with a base that's the same base over here. So that'd be 4 squared to the x minus 1. Now I want to point out I didn't multiply both sides by anything. I didn't divide by anything. All I did was rewrite the way I'm saying 16 so that the base here and the base here would match. Of course, the left side's not going to change at all. And now I'm going to use my properties of exponents. If you have a power raised to another power, you're supposed to multiply those powers. So the right side could become 4 to the 2 times x minus 1 is 2x minus 2. The left side, of course, remains unchanged. And this is good. Now that these bases match, I don't really need them anymore. I mean, I'm going to find a number that makes these work, but if it's 4 to some power over here and 4 to the same power over here, of course they'll be equal. So I really just need to figure out when x plus 3 equals 2x minus 2. Now to solve a problem like this, of course, we're going back to our Algebra 1 skills. Before I even worry about reverse PEMDAS, I want to get all the x's together. I like to keep the coefficient on x positive. So the first thing I would do is subtract an x from both sides. The left side will just have a 3. 2x minus x is x minus 2. And then, of course, to finish this off, I'd add 2 to both sides, getting x equals 5 as my final answer. These are difficult to check sometimes because they make your calculator give really big numbers. But if you did want to plug in 5 and take 4 to the 8th power and take 16, something does not seem right here. Oh yeah, 16 to the 4th power. Then we should be good. Good luck.